In this example, we are setting out to calculate how to prepare two serial dilutions of 0.05 and 0.01 molar from a stock solution of nickel 2 nitrate. Our solution number 1 will have a molarity of about 0.05 molar, and solution number 2 is about 0.01 molar. Notice that these values, the 0.05 and the 0.01, are not actually recorded with one sig fig. Instead, these are what are called nominal values. A nominal value is an approximate value that does not take into account the sig figs yet, because we have to wait to see which specific measuring devices, which pipettes and which volumetric flasks we're using, and then we'll incorporate the sig figs into the calculation. What we'll end up doing is two calculations. We'll have two calculations for each solution. First, we'll calculate the volume that we need to pipette. We'll figure out what that volume is from a practical point of view, and then recalculate the molarity of that particular solution, incorporating the proper sig figs. You'll see how this works. The solution that we're dealing with is nickel 2 nitrate. So we'll just go ahead and write that down so we know what the chemical formula is. Because all of these calculations involve dilution, there are no grams anywhere. We don't need a molar mass, but it is helpful, I think, just to see the chemical formula. After all, this is a chemistry class and this is a chemistry calculation. I want to make one comment about the precision of the glassware. Most volumetric glassware, most volumetric pipettes, and volumetric flasks have a precision of 2 decimal places. In other words, we report them like the 25 ml flask out to 25.00, out to 2 decimal places. There are a few differences, and you should be aware of what those are. The first difference is that the 1 and 2 ml pipettes are precise out to 3 decimal places. So we need to have 0.000 for those. And volumetric flasks that are greater than or equal to 250 mils are only precise out to 1 decimal place. So that makes it pretty easy to remember. You just have a few exceptions to that 2 decimal place rule. So for solution number 1, the first thing we're going to do is define our terms. So let's remind ourselves of what that dilution equation looks like. It's M1V1 equals M2V2. And what we're doing sort of conceptually as we are defining the terms and doing the calculations, the scenario that we have is that we will pipette V1 milliliters of solution M1 into a volumetric flask of V2 milliliters to get solution with a molarity of M2. So if you can think about the order of how we're doing these operations, it helps to keep the terms straight, so that way you don't mix them up. Defining our terms for solution 1, M1 will be the stock, 0.08014 molar. V1 is what we're trying to calculate. What pipette volume do we need? M2 is the solution we're trying to prepare. So solution number 1 has a nominal molarity of 0.05 molar, and the volume that we are going to prepare is 25 mils. When you're using an equation like the dilution equation, you want to make sure that you rearrange the equation to solve for the variable of interest first, then plug in the numbers. So rearranging this to solve for V1, we end up with M2V2 over M1. We'll plug in the values. We're not going to worry about sig figs just yet because we want to see what is the approximate value of the volume that we get, and then we'll go to our available pipettes, our available volumes, and we'll choose one that is the closest one. Plugging in the values, M2 0.05 molar, V2 25 mils, divided by M1, which is 0.08014 molar. Cancel the units, so molarity will cancel. Doing the calculation, we have 0.05 times 25 divided by 0.08014, and we get, rounded to 2 decimal places just for right now, we get 15.60 milliliters. Now we don't have a pipette that has a fractional volume. So we go to our list of available pipettes and we see that we have a 15 ml pipette. So that's what we're going to use. So the next step is that we're going to recalculate the molarity because it's going to be slightly off from 0.05. And first of all, we do that because we want to know what the molarity is. And second of all, we want to know what that molarity is out to the proper precision. In other words, what are the proper sig figs? So we recalculate M2 using the proper sig figs for the measuring devices. M1 is the same, 0.08014 molar. V1 we know, we're setting that at 15. Include the zeros now because we're taking into account the sig figs. M2 is what we're trying to calculate because we need that precision. And V2 is 25.00. Rearranging the dilution equation to solve for M2, we end up with M1V1 divided by V2. So we'll plug in the values. M1, 0.08014 molar, times V1, 15.00 mils, divided by V2, which is 25 mils. Our molarity has 4 sig figs, and both of our volumes actually have 4 sig figs. So our final answer will be rounded to 4 sig figs. So when we do this math, 0.08014 times 15 divided by 25, we get 0.04808 molar. So you can tell that's pretty close to 0.05, but with the proper precision, now we can see what it actually is. So that's solution 1. We're going to do the same types of calculation, we're going to do the same types of calculations for solution number 2. And our molarity that we're trying to get is about 0.01. So we'll set that up now. So we have solution 2. M1 is not the stock solution anymore. It's the previous solution that we're using in our serial dilutions. That's 0.04808. V1, we're still trying to calculate. M2, as we just said, is about 0.01 molar, and V2 is 25 mils. So we already rearranged the equation earlier. V1 equals M2 V2 over M1. So we'll plug in these values. M2, 0.01 molar, V2, 25 mils, remember for this first calculation, we don't need to worry about sig figs, divided by M1, 0.04808. Oh, I just realized I forgot to cancel the units in the previous M2 calculation, so I'm going to backtrack and do that now. All right, coming back to this problem, sorry about that. We'll cancel the molarity. So we have 0.01 times 25 divided by 0.04808 gives us, rounded to 2 decimal places, 5.20. We don't have a pipette with that volume, fractional volume, so we'll use the 5 ml pipette. So now we're going to recalculate the molarity, taking into account the sig figs. So M1, 0.04808 molar, V1, 5 mils, 5.00. M2 is what we're trying to figure out, and V2, 25.00. So M2 equals M1V1 over V2. Plugging in the values, we have 0.04808 molar times 5 mils, 5.00, divided by 25.00. So I'll cancel the units. Won't forget that this time. And we'll check our sig figs. So we have 4 sig figs in the molarity, 3 sig figs for the 5 mils, and 4 sig figs for the 25 mils. So for this value, we need to round it to 3 sig figs. So doing the math, 0.04808 times 5 divided by 25 gives us 0.00962 molar. That's pretty close to 0.01, but again, we're dealing with the proper precision here. So we've done the calculations. Now, just to give a brief summary of what we ended up with. So for solution number 1, and this is related to how the solution is prepared, we will pipette 15 mils of 0.08014 molar solution into a 25 ml flask. We'll filter the mark with DI water and mix. And that's how we're preparing solution number 1. Sorry, the handwriting's getting a little bit sloppy here. For solution 2, we pipette 5 mils of 0.04808 molar, which is solution 1, into a 25 ml flask. Filter the mark with water and mix. I know it might seem redundant that I'm writing it all down twice, but it is important that you understand what solution prep looks like, because there's a practical aspect to it. It goes beyond just the calculation. Let me back up to solution 1. So I've written out that procedure, and after we mix it, we have a solution that's 0.04808 molar. And for the second one, we end up with 0.00962 molar solution.